class?
Yes.
Tree. For people watching, Tree actually shook his head at me, so that was, I got a head nod. I don't know if he's just jamming out to the music, or actually agreeing. But I'll take it as an acknowledgement. Okay. Trying to finish up this unit right here. Obtaining information about a graph of a function from the graphs of its derivative. What is the domain of the derivative of f? So if this is continuous for all real numbers, and this is my function, what do we know about the slope of this right here? So let's start with the first part. What do we know about the slope right here? It's going to be a positive slope, right? It's increasing on the interval from where? From negative infinity, right? Looks like it keeps going. So it's from negative infinity to 0, right? And how would I close that 0? Parentheses, because at 0 I have a kiss my asymptote. There we go. See, I gotta get some pleasure out of, math jokes somehow. All right, so right here, so the domain, so that means that right here, it doesn't exist right here. Picks up again on the other side is 0. And then, what is this thing right here? Discontinuity, right? That's gonna be a jump right there, isn't it? So the domain would be from all real, okay? So domain of the derivative of the function. So I can't take a derivative there, and I can't take a derivative there. But I could take a derivative everywhere, right? Everywhere else. So that means my domain of this is going to be from negative infinity to 0, close, union, open, 0, 2, close, union, 2, infinite. Critical numbers of f are at x equals and 2. What numbers x, if any, does the graph have a horizontal tangent line? Does it have a horizontal tangent line anywhere? None. At what numbers x, if any, does the graph have a vertical tangent line? Now, this one right here, for a line to be vertical, what has to happen? It has all rise and 0 run. All rise so let's say if it's 5 rise, 0 run. What does that give us there? Undefined, right? So if I were to try to do this, and I would actually have a graph of a function, let's take a look at this. Right there. At those 2 points right there, what is that? I'm gonna have undefined, right? So this right here being vertical, so depending on what it is, I can't graph this as a function. So on your calculator, you can't ever graph a whole circle, right? What does it fail on that circle? vertical line test right there. So I can't graph it like that. And then over here at these points, my tangent's going to be undefined anyway, right? So I can't take a derivative at 0. And this one right here, it does have a, I could say that it does, but this one right here is questionable. So this one right here would not be a vertical tangent line because it would not show on my function because it says it's continuous for all real numbers. So this one right here, graph of the function. So if it is a function, then it can't have that right there. So this one also is going to be none, because that one there is an asymptote. But when you're looking at it, you have to really clearly see rise over run. I can have a vertical. I can, because some of the things that we're going to do is we're going to try and find a vertical tangent line. And we know with vertical tangent line, it has to be undefined. Some number divided by 0. That's going to give me my rise over run of undefined. At what numbers x, if any, does a graph have a corner? Okay, what was a corner? What do we call those? Okay, do we have any there? No? No pointy points, right? Okay, so none. On what intervals of a graph increasing? Okay, this is a good one right here. So intervals that it's going to be increasing would be from negative infinity to 0 close. What about decreasing? Start at where? 0. What am I using? Parentheses. Very good. So, to what? 2. Parentheses. Union. Union, right? Parentheses and 2 onto infinite, right? And beyond. No Toy Story jokes? Too early in the morning, right? Okay. Did I break it? Very good. Okay, application. Agricultural economics determining crop yield. Variation of the von Ligberg model states that a yield, f of x, of a plant measured in bushels corresponds to the amount of x potassium in fertilizer according to the following square root model. For what amounts of the potassium will yield increase? For what amounts of the potassium will yield decrease? So, increasing and decreasing, that means increasing means I'm going to have a what? If it's increasing, what would I have? Okay? Very good. Positive slope. Super basic, right? Positive slope. And then, if it's decreasing, I would have a negative slope. Okay? So in between those positive and negatives, what do I have? I have a what? A 0. And 0 gives me critical points, right? There's my critical points. So now we talk through the problem and I say, okay, I know I need to figure out the derivative, positive and negative, but in between those positive and negatives, I have my critical points, which is going to be equal to 0 or what else? Undefined. Very good. So on this one right here, is it going to be undefined anywhere? What can I not have? I can't have negative numbers, right? I can't have negative numbers. So my domain of this is going to be positive, right? Real positive numbers. So it would be from 0 to infinity. Okay, so let's go ahead and do this then. So from here, let's take the derivative. So I get f prime of x equals negative 0.417 plus what? Anyone math this one? Remember, this is going to be x to the 1/2. Taking the derivative, I take it out front, I divide this by 2. Right? 0.426 x to the negative 1/2, because I still got to subtract that. Now I'm going to rewrite it. F prime of x is equal to negative 0.417 plus 0.426 over x to the 1/2. And to be able to combine these, I have to have common denominator, right? So common denominator right here. So what do I need to do to actually make this have a common denominator? Christian, you want to help me out? You're helping me out with everything else so far. You got this. Multiply this one here, right? Because right now the denominator is, so I need to multiply top and bottom by? No. It's got to be a common denominator. My denominator is? Yeah. Top and bottom by x to 1/2. So, rewrite it. F prime of x equals negative 0.41 negative 0.417 x to the 1/2 plus 0.426. All this here, by having the common denominator, is x to the 1/2. Are we okay so far? Yeah? Okay, so critical point says I do what? Set this here equal to 0, yeah. So I got to get my critical points first, so set it equal to 0. Four, 1, 7. Plus 426. Multiply both sides by x squared, so that's going to clear that out. So I get 0 equals negative 0.41 7x 1/2 subtract I get negative divide by and I'm gonna bring up the calculator because can't really do that one in my head very good. Uh, 978873. There we go. Equals x to the 1/2. And how do I undo that? 1/2. Square both sides, right? So square both sides. I just copied it over so it has the whole number. And that's going to be 0.958. Going back to the problem. Amounts of potassium. So, in the fertilizer, measured bushel responds to X potassium of fertilizer. So, that's how much potassium we need to actually add for each. And so that's going to be my critical point where it's going to be equal to 0. So we're going to take my derivative over here. I'm going to take my derivative. I could either use this one here or I could use this one here. Doesn't really matter. I'm going to plug this in here, and since we're using the calculator, I'm just going to put that there. Let's into the thing so we had negative 0.417 plus 0.426 x raised to the negative 1/2. Oh, dang it. I didn't see that. There you go. So it looks like right about 1. Isn't that what we had as a critical point? Okay, so if I'm looking at it, right about 1, that 0.95, blah, blah, blah. To the left of it, it's positive, right? So what does that mean if it's positive to the left? Remember, we're talking about the derivative here. This is the graph of the derivative. So to the left of 1, what does that tell me? It is increasing, right? This is the graph because if it's above the line, it's positive. and if it's below the line, it's negative. So if I were to graph the original on top of this, you could actually see right here, hit tab, and my original, can someone read me the original, please?
The original function?
Yeah, the original function.
Negative 0.057
Dang it. Negative 0.057
minus 0.417x plus 0.852 rad x.
like that.
Uh,
There you go. So looking at this, if this is my original function right here in red, then I have a critical point right here. So right about there. So that's going to be my min-max right there, right? And so to the left of that, it is increasing to a point, and to the right of that, it starts decreasing. So the amount of potassium that is going to be is going to max out right about there. So after that point, then it starts decreasing. So if I put too much potassium, that is going to start killing the plants. And I get less yield. It starts not being as much as what it should be. So the maximum to actually get the most out of it, the yield, is going to be my, right here. Does that make sense or nonsense? Vincent, we okay? All right. So make sure you guys like, share, and subscribe. We're going to keep working on homework. So bring your homework questions up now.